Hello and welcome to this episode of Math with Martinez. We are in our 7th unit in Algebra 2 where we are looking at cubic and cube root functions and equations. And today we're going to be analyzing cubic and cube root functions. We're doing this in order to see what the relationship is between a function and its inverse. So let's begin to investigate these two functions. In red, we have the function y equals x cubed. That is our cubic function. And in blue, we have our cube root function. That's y equals the cube root of x. So let's focus in on that red function to begin with. And I actually want us to complete this table below for the parent function that's graphed up above. We're going to find some points in the graph, and then we're going to plot them on the table down below. So let's find some points on our red graph, and specifically some nice, what I might call pretty points, points that are at integer values. So as we read it from left to right, here's what I come across. The first point that I come across is right here. This is the point -2, -8, because the x value is -2 and the y value is -8. Then as I'm traveling along that graph from left to right, none of these are nice, but right there, right here, we've got another point that I can identify. That would be the point -1, -1. As I keep tracing, I'm going to see right here is the point 0, 0. And then I get to this point right here, which is the point 1, 1. And I keep tracing all the way up until right here, almost outside of my window. That is the point 2, 8. So let's go ahead and take these points and write them in our table. So when the x value was -2, the output was 8. -8. At -1 for x, the output, the f of x, was -1. 0, it was 0. When x is 1, the output is 1. And when x is 2, the output is 8. And we see that there graphed. Now, what I want to show you all is the fact that these points are actually just going to be reversed when it comes to that parent cubic function. So where exactly are they being reversed? Well, let me show you. Instead of this point, -2, -8, we're going to have the point, check this out, -8, -2. The x and y values switch. At -8, -2, we see that point right here. That's -8, -2. Also, it doesn't look like a whole lot to switch this around, but when we switch the x and y of that red graph, -1, -1, -1, -1, the switch of that is also here. -1, -1 graphed on my coordinate plane. Also, and when we switch 0, 0, it is 0, 0, and that point is graphed and part of my parent function. The point 1, 1 is graphed. And then also, we should have the point 8, 2 instead of 2, 8, and that is right here. Now, what is beautiful, what I want you guys to see here, not only that the points are switching, but what does that mean visually? Now, looking at the graphs together like this, it's really neat because what's occurring here, let me sketch this line in. This is the line y equals x. And every one of these points is actually a reflection across that line. What do I mean by that? Well, each of these points, let me kind of connect them for you here. These points reflect across that line. They are equidistant, perfect reflections across that line from one another. Now, the 3 in the middle, they actually fall on that line. -1, -1, 0, 0, 1, 1, they are on that line. And then this point over here, 2, 8, and 8, 2, reflecting across that line. The distance, this distance right here, perfectly reflected onto the other side. We have this symmetry that is existing between these points across this line. So let's take a moment and write that in the margin, because this is a really big idea. The graph of a function and its inverse function will always reflect across the line y equals x. This is a big deal. This allows us to visualize and see if two functions are in fact inverses of one another. How will I know they're inverses? Because they'll reflect across the line y equals x if graphed simultaneously together. So the function values, they switch. The x and y, they switch with one another. The domain and the range of inverse functions will switch or will reverse with one another. When you graph them and look at it in a coordinate plane, those points will be reflecting across that line, y equals x. That's all I wanted to share in this video. Just a short, sweet analysis, both graphically and from a table, of inverse functions. That's it for today. If you guys had any questions, would you please take a moment and share them now? And until next time, stay fired up.